Hello. I still have problem with sync. As usual. It's not that important, but it's annoying. It's not that important, but it's annoying. Ah, okay. That's about okay-ish, I think. Hopefully the sound is a little bit better than last time. Less noisy. Hello. So, I was making a coil. At least that was the plan. So I'll switch. Ah, that's me. So this is FEMM. I was playing with FEMM, and then after it I'll make the coil. If you got any questions about FEMM, then just shoot. I might be able to answer them, but not too sure. I mean, I'm not like a professional FEMM user. Also, the controls are like, I don't know, really weird. It's like 70s, 80s, well, of course not 70s, but it's like 90s, 2000 controls or something. Older, I guess, even. I don't know. It just sucks. Oh, here, I did something already. What is the image right now? Okay, a blank canvas. So let me zoom out. So what I did, I was doing this Halbach array. So that's a weird contraption of magnets, like seen here. So the point, I'm not sure if the point is pointing to the north or south. I don't know. There must be a rule for that, but I don't know it, and I don't really care. It's all relative. I mean, if you just pick one and use it correctly all the time, then well, you're good to go. So this is a Halbach array, and it prevents magnetic field forming on the bottom side and makes it bigger on the top side. So if you would like analyze this, then a few results, then that's the wrong one. I have to like, and you get this. So this is how it looks. So the bottom side, there is hardly any field, and the top side has most of the field. So it's actually kind of directing the field to one side by, yeah, you know, change the magnets like 90 degrees every now and then. It's still kind of, I don't completely understand it. I've seen some where I kind of get the idea, but then I look at this one and I'm like, why? But well, it is how it works. FEMM is, I'll show you a really simple setup, just drawing a magnet. So if you have FEMM, because that's the biggest problem I think to start with FEMM, is you have to make a huge outer line and then determine that this inner part is air. That's where you start off. I didn't do it like quite nicely. It's just 4 points and then 5 of these lines, and then I put a, what is this called, block label, I don't know, and I called it air because it is air. But you start off by, let me see, material library. There you choose the materials you're gonna use. I use air, it's here. In this case there's also ceramic 5. Not gonna use it, but I don't know why I added pure iron, because it's nice to have some steel. Could be another steel as well. I just chose this one. And 2 types of neodymium magnets, 2 grades, 37 and 40. So it's in these lists. Here they are. And soft magnetic materials is steel, etc. Then I create 4 points, draw 4 lines, and call the inside like this. Right click on it, press space, and then choose air. This is air. Having two of these things, calling it air, is gonna fuck up the program. It's not gonna work. It's really like bitchy about a lot of things. If you forget, for instance, if you create, I use 4 points, and I'll just do it like this, make a sort of boundary about it, around it, and not call this something, I cannot analyze it. It gives me an error. So I have to say it's something. For instance, right click on the green thingy and press space. This is a, well, it's a magnet. And north or south, still not sure, is pointing to the right. You can change that again by right click on the green label, press space, and then change the direction. For instance, if I want to point it upwards, I think it was 90 or 270, 90 it is. And then we got a magnet with north on top and south at the bottom, or the other way around, because I still don't know which one is the arrow. If I analyze this, it should work. So you first analyze it, then you view the results. Then I'll look this magnet up. This is the magnet. No. That's one beautiful magnet. So if I want to remove something, I really have to select if I want to remove lines, points, or labels. Or if they are called labels, I'm not sure. I'm calling this labels. So if I want to remove these lines, I have to select the line thing, then the selection tool, and remove it. Same goes for the points. It's that annoying. But anyhow. So this is the Halbach array, and well, we can analyze it and see what the difference is. I mean, we could see it in the colors, but let's see what it actually is. So I'm putting these points here because I want to draw a line later on and analyze what the field strength is doing above this height above the magnets. In this case, my grid size is 1 millimeter. So these points are 2 millimeters above the magnets. So if I analyze this, then few results. I'm gonna have to look it up. That's not it. Here it is. There's a red line here we can select. And this is where you're gonna be able to do several measurements. I'll show you later on. So I'm gonna draw a line from here to here because I want to know what's happening here. Then we use this graph thingy, and then you have several options. To me, I'm not that much into magnetics, but I know if I want to make planar magnetics, I will be using this tangential flux density, and for Rubanoids it will be magnitude of flux density. It depends on how I think it depends on how the magnetic field, in which direction it's moving. If I just do, let me pick this one, you'll notice straight away. So I'll choose this one. Well, you got a result, but it's kind of a mess. There's a amount of Tesla, but it's kind of, you have no clue what's going on. So if I receive a image like this, I know I chose the wrong one. In this case, I need to choose this one. Then I got this weird thingy. Yeah, sort of a V. If you look at this picture once more, then it correlates with this magnet here and this magnet here. It is, let me see. This was the one we created. So 0 to 5 millimeters, it goes up to 0.4 Tesla. So that's here. and then it drops down the other way. So now it goes almost to 0.5 Tesla, but the magnetic field changed. It's in the other direction. It passed the 0 here. So that's here. And then it goes up again and does it once more. That's here. Ain't that weird? Yes, it is. I think this was the kind of this setup I cannot use for a Rubanoid, for instance. If I just make the same array and like kind of swap it, or what is it, mirror it above it, I get some really weird things. So this is what I made in the end. It's made of all kinds of small magnets. I can show you here. It's kind of messy because I don't have the right size magnets. So this is more of a mess. And the reason is because, well, it would be nice to have magnets that are like 5 by 5 times 30, for instance, but I don't have those. I only have 5 times 2 times 30, and I do got some long 3 by 3 times 30, which are nice, but they're a little bit more expensive and doesn't give me a wide magnetic gap. I'll show you later on. So I made this contraption of 12 tiny magnets aside, so 24 magnets in total. It's the same Helbach array, except in this case I really have to look up the differences myself. So this is pointing left, down, right, left, up, right. So the field is gonna project downwards. Notice this, that the magnets here are also pointing upwards. That's the difference, the mistake I made when I first started off this. So the magnetic field is gonna go from this magnet to this magnet instead of to the next rows of magnets, because that's not what I want. I want magnetic field going from here to there, or all the way around, don't care, but not like this, which you will have in a normal planar magnetic, for instance. And then you can, of course, use the rule, the magnetic rule, what is it, the left hand rule? I forgot, I once made a mistake, if it was right hand or left hand rule, I don't know. Well, if you would make it as if I would do the same as we see here, except use this setup, this one, then the coil that's gonna sit here and here is gonna move this in this direction instead of this direction. But okay, you use the arrows, yeah. So that's only if you look at the colorful drawing, then that's nice. If you want to like see when it's switching, and that will show you not right now. I made this magnet setup, and then what I want to know is how much coil can I cramp in there. I mean, we're looking at the top, so remember, this is a top view. All these magnets are 3 centimeters long, but we don't see it because it's 2D and we're looking from the top. So what I'm gonna do, I already put some points here, all over the place actually. And what I'm gonna do, I'm gonna analyze it. A few results, then we got this, okay, nice. All purple and such, that's good. I'm gonna use this red line tool thingy again. And what I wanna know is, okay, first of all, let's do the complete thing. See what's happening to the field. Now I can use magnitude of flux density instead of the tangential thingy, because the field lines are different. than the previous one. Is that true? Wait a second. Am I fucking this up? No, I'm not. You see, this is something completely out of this world. A normal flux density I could use. Yeah, that's better representation. Because now it does this as well. So we can see that at 5 millimeters, it's almost 1 Tesla. That's quite nice, to be honest. And then it drops off, and then it reverses the field, also 1 Tesla. Then it goes up a little bit again, once more. Well, no, it's not. It's going down, actually, approaching 0 magnetic field. So this is what we were interested in. This part here and this part, but that's a mirror. So if I want to make a coil, I want to know, you want the coil to be in the strongest field, but of course you could only use like this part. That would be like not even 1 millimeter. I cannot cramp much coil in there. So I will take it a little bit lower and see how much millimeters we got to play with. So I'm gonna zoom in, because this right one here and this left one here are the same, except reversed in polarity. So what I'm gonna do, I'm gonna select this part, normal flux density. Now we get like a zoomed in view, and now we can see that if you would like to have like 0.9 Tesla, and we want the coil to be in this place, it starts around 0.5 millimeter to around 4.5. So we got 3.5 millimeters. 1, 2, 3.5. Not 4. We could use like 4 millimeters of space, or if we're okay with it, the whole 5 millimeters. But then, yeah, there's a piece of coil not sitting in a perfect field. That's no problem. You can do this. That brings me to overhung and underhung coils. So underhung coils, that means that all of the coil will be, if you look at the gap, the magnetic gap, the width of the gap, all the coil will be within this gap. So where it's like kind of straight. And then it can move a millimeter or what, something, I don't know. And then it's perfectly in the field all the time. The other option is make the coil much wider. It will lose, it loses some efficiency, but it could extend your X-max. So if you're going for like more X-max, lower efficiency, you could do that, because there's always the same amount of coil in this magnetic gap, in the strongest part. So that's an option if you want higher excursion and not so much perfect linear thingy and very high efficiency, or at least higher. But of course there are some practical reasons. So for instance, if I cannot reach like a decent impedance in 3 millimeter width to cramping coil, yeah, well, what can you do? You can do a few things, you know. Go thinner on the wire and get to that desired impedance, or make it overhung and, well, you get to the desired impedance and probably have a little bit more power handling as well, because you used thicker wire. Fergus, I could email you a paper on the M-array arrangement. The M-array arrangement, what's that? One and a half Tesla in the gap with only 2 magnets. What? Getting them made, because okay, so they do need some specialized magnets, I guess, because that would like fuck up the whole idea of keeping it simple. I mean, getting higher Tesla is nice, but only if it's doable. I must say, I mean, this is 1 Tesla going to 1.5. You know, it gains a few dB, not all that much. So after a while, the question is if it's worth, you know, pumping out the last tiny eeny beeny bit of Tesla. Although 1.5 and 1 is quite, of course, it is quite a lot. But yeah, if you can post or send me that would be awesome. Hopefully I understand it, because I'm no expert. Could you potentially maintain a high magnetic field and increase the width of usable area by spreading the Halbach area, or does the effect rapidly drop off when spaced? You mean if you space out the magnets in between? Because that will screw up the whole thing. You can see it's 5 millimeters. That is, well, a little bit less. That is practical, and the reason for that is the magnets, these are 5 millimeters wide. So that's your answer. What you can do is get bigger magnets. So if these were, for instance, 6 millimeter wides, we probably had like 5 millimeters of usable area in a high field, and maybe a little bit higher field even. So this is just made up of magnets I've had laying around, tiny ones. Oh, I cannot show you the array itself, but let me see. This is gonna be out of sync because my webcam thingy is kind of weird. It's not working. So this is the Rubanoid motor. It's hard to see, but I put this array in these plastic blocks. This array we've just modeled. And the reason is it's quite hard to make, because all these magnets, in the way they are right now, they don't want to be together. So to put these together is not as easy. I found a video of a really nice trick to make it a little bit more easy with 2 metal plates. That worked for me, but he used some glue as well, but he always had the magnets on the plate. And the reason for that is that if you have the magnets along with the glue, the chance that it just like lets go and just flop, spring all over the place and destroys itself is quite high. So a backing is nice, although of course there is one weak side, so it's not like really sticking. So I pocketed in the plastics, sort of, a pocket, so I could drop in this whole array thingy after I glued it together. It held up long enough to put it in there, and just use a lot of cyan acrylic because I run out of epoxy. I would use epoxy otherwise, but it works out so far. It's sitting there and it's rather okay. The gap width, or I think it's called the gap width, and the other one is the height. So the gap width is 3 millimeters. So that should be enough room for me to put a piece of paper in and a coil or something else. Depends on what I want to use, of course. But so yeah, this is the array. So let me decide how wide I want to make it. I'll go slightly overhung and just use 5 millimeters to make it easy. Depends on what you want to make, of course, but if you don't use wire, I'm gonna etch the coil. So a wire is thinner than most traces when etched, so I'm having trouble getting it really slim. So I'll use 5 millimeters or around 5 millimeters. So this is the array drawn in SketchUp, and well, I am gonna use this part. This is gonna be my coil there, or at least a part of the coil. I mean, it's a flat coil. So we're looking at the top still. So this is a part, for instance, here the wires or the edged traces go up. So from the monitor in my face, and here from my face into the monitor. Now I know this space I don't want to have any coil, or at least not much. So that's 4 millimeters wide, but I work in a 1:10 ratio thingy, so that will be 40. And my magnets are 30 millimeters long. And here we got the magnets, those are 5. This is also a magnet 5. So this is a side view. And then I want to keep at least 5 millimeters above the end of the magnets where I want to make the turn on the coil, because magnetic field is going, well, let us check that, to be honest, because that's why I made these points here. So I want to know, you can see here there's still some colors, and I want to know how far does this random field extend, because it will have influence on the where the coil turns. So let's see. Oh, so I'm interested in this part actually. So here it is. Wait, that's weird. So the field here is still like 0.34 Tesla. So I don't want coil here. Well, we decided to have coil here and here, so that's no problem. But so I got this room here. I don't want to go past this green gap. Okay, I'll just use my 5 millimeters and I will be safe. So what I'm gonna do, I'm just gonna group this, make it a component. I'm gonna, I don't know, give it a color or something. Transparent thingy would be nice if we got one. Glass maybe? I don't know. Ah, fuck. Might be hiding it. Like this. So we got 5 millimeters, and now the calculation stuff begins, which is annoying because it's still a gamble. So I'm gonna use foil that is 9 micron thick. 9 micron thick. And the length of the coil is gonna be, why is this, oh wait, at least 30, and this 5 or 50 millimeters. I want it to be above. The magnets. So one of the traces will be 40, and then of course you got the turn it's gonna make here. So this is usually a guesstimation. First of all, I know that my trace distance need to be 0.3 millimeters. I thought about using maybe 0.5 millimeter traces. So that would be 0.5 plus 0.3, so 0.8. 5 divided by 0.8 will be 6.25. Then again, we don't need the spacings on the outer side, so what I'm gonna do, I'm just gonna draw it. It's the easiest way. So 5 millimeter trace, 0.3 millimeter spacing, 5, 3, nope. I'm gonna copy that a few times. Okay, so my coil is gonna be slightly less than 5 millimeters because this is the spacing of 3, but I cannot fit another 0.5 millimeter coil. So either I make the coil traces a little bit bigger, or I'll leave it at this. So this is 4.5 millimeter. Let's see what resistance we got if we used something like this. And this is like a really, it's not very precise, but it's okay for me. I don't care much. So we got 1, 2, 3, 4, 5, 6 traces, times 2 of course. So 12. 12 times, what was it, 40, and this distance, which is, well, I'll just guesstimate it to 1 centimeter. Wait, 12 times 5, so 60 centimeters, that's quite long. Let me just put it somewhere because I forget. Now we got my favorite sides is like, because I don't have a calculator here, and I'll just use calculators because why not? So first of all, I need to have like the surface area of the trace. In this case, that will be 0.0. This will be 1 millimeter, 100 micron, 10 micron. Am I correct? This will be 100 micron, 10 micron, 9 times 0.5 millimeter. This number is the surface area. And because the next calculator only works with diameter of wire, so I'll have to use this. Here I choose aluminium. This doesn't work with a comma. And we had 60 centimeters in length. So that will be around 3.5 ohms. That's perfectly fine with me. Probably it's a little bit higher because I didn't calculate the turns rather accurate. So this could be in between 3.5 to 3.9 or something, which is decent, I think. 450 millimeter, pretty small. Yes, it's a quite small coil. I hope I'll manage to do that. So then it's just I used a like you know, the stuff for making PCBs, and actually this is SketchUp is easier to do this. It's ridiculous but true. It is kind of weird. So I got my traces here. I'll just cut them. I'm gonna make a group of them as well. And I'll find the middle, which is here, and dump it on this magnet, find the middle as well, and then move it to the position I wanted to make the turn, so 5 millimeters above the magnet. I'll copy it and do the same underneath. And let me do the same here. And it's really, I could have done this easier, I've noted. Come on. Now I'll just copy those. So we got our traces here. So here is gonna be the coil connected to whatever, a am I fucking this up? Yes, I am. I hate when this happens. Oh. I want to have it all in their own groups. So I can slide the coil aside if I want to. And I don't want this to be hidden. Oh, I screwed up. I can see what I'm doing. It's a mess. Wait. So we got a coil. Ah, there we are. One second. There, create a group. Thank you. So I'll just clean it up real quick. Okay, so this is somewhere where the connection point will be. Not sure how it will look yet. We'll see. I'll just make something here. It's not nice, but we're gonna go for round or square. I think I'll go for round this time. It says half circle. That's good. Then you know you got the correct width. Yep. You see, this is incredible simple. There, we got our coil. And then we have to create some connection point here as well. That would be nice. Like so. Let's not move it too much to the other side. It's not gonna be added at CNC general, so you're into CNC. I don't think I'm gonna edit this. It's just a as we go thingy. I might make a video about it if I have an idea how to make it normal without too much weird stuff. So this connection point could actually move over here and flip it. Like so, and then make something like, ooh, that's dirty. something more like this. Why? Because that's nice. Then these are just strips, not stuff hanging on the side. When design traces to use some of the magnetic field on the outer edge. No, I wanted to not use the field if I can. Am I able to make this a bit longer? This is just random stuff. I mean, you can do as you please. So for instance, I don't like this sharp edge there. That could be nicer, I think. More like this. Yeah. So that's coil. So now we can move it just like. And we should have a rather decent impedance as well. Power handling will be quite shitty, of course. I mean, it's 9 micron film and the trace width is a 0.5 millimeter. I hope my printer is able to do that. Let me clean up this edge as well. Let's just choose a random spot here. No. So yeah, I hope I am able to solder to this as well, because it's 3.5 millimeters wide. That's not very huge, but we'll have to. I mean, there's no other option. So yeah, still quite a big coil if you compare it to the magnets. So it might be able that I need to like squish this. I don't know. Since now it's 40, well, we can squish it a little bit, get a little bit lower impedance. Then again, this connection point will be in the magnetic field, so that's not good either. I'll revert back. Yeah, now the question is, are you gonna etch it? Well, I'm first gonna export it to CAM. So I'm gonna copy this one and save the thing. A new SketchUp, top view, I'm gonna drop it here, I'm gonna explode it, export it as a 3D DXF model. Coil. Gonna open Kanban. Gonna open the coil. Switch to millimeters. Make it the actual size it is. So I have to scale it down 10 times. Now I'm gonna join it up and see if there are any faults. Edit. Join. So it's like one polyline now. I'm gonna, usually what I do is polyline remove overlaps, delete this one and use this one, and polyline clean. Oh, there was nothing to clean. Okay. So now this should be, I should be able to export this one, DXF coil 1 on 1 in dimension, so this is the correct size. I'll use Illustrator. Try out, is it? Open the 1 on 1. That's not it. I always call them 1 on 1, so that's the one. It's gonna be coil heaven. How many coils do I need? Not so many, I think. It would be nice if they lined up so you can cut them in one go. So that's what I'm doing here. I think half a page will be more than enough to see if it doesn't work. I mean, what the fuck do I need so many coils for? Although I'm pretty sure if I'm gonna play Rubanoids, I'm definitely gonna use a gazillion different materials to see what it does, and then I fuck up a coil and whatever. So having a few coils is quite nice. It's better than winding them. Of course, winding, it has its benefits. You can cramp in far more wire than I do right now by etching it. I mean, I only got 5 turns or six turns. Well, with wire you can of course pump in much more turns if you want. But making a flat wire coil with these radii is quite hard. So yeah. Well, I actually did what I wanted to do faster than I thought I would. So it's kind of boring, I know, but I'm sorry. If you got any questions, maybe or about FEMM, although I'm not like expert in FEMM, but at least I usually get what I want from FEMM. But because I am gonna etch these coils, but I'm not gonna like do the whole filming thingy again, because it makes it 10 times as slow. Twenty coils, yeah. Is it? You counted them. Yeah, so I could make 40 or maybe more in one go, and probably a few fills. So that could work. So next up will be designing a membrane that could like hold the coil. And the first try is gonna be, I think, just normal ordinary paper, because back when I played with Rubanoids, paper worked out rather okay. And it's of course simple, and it damps really well. Far better than plastics or something. It's also much lighter than most plastics. So I need to find a way to make different membranes quick. So I'm guessing what I'm gonna do is gonna draw a membrane and use the plotter to cut them out on the CNC. So I can just make a few from different kinds of paper. So it doesn't take a gazillion years to make a new one every time. Then the next question is how you're gonna adhere the coil to the paper. That's still something I don't know. I want it to be quick. So a spray glue works, but it damps as well. So rather a rigid glue and fast. So that's a lot of options. So not really. That will be cyanacrylate is an option, but it works. It's not perfect. It's messy as well. Epoxy, but it's not fast, and it's also not very hard. It's more like gummy. I need something that is making the paper stiffer than it normally is at the coil. So I thought about yeah, maybe, let me think. I have this stuff for gluing fabric. That's also funny stuff. It's like these sheets of hot glue, I think it is. That's an easy way of 30NF. 30NF is also rubbery. So it's a bit like spray glue. It's a contact adhesive, so it is a bit like other stiffer PVA. But PVA, yes, but PVA doesn't glue, I believe, mylar to paper very well. It does. It is nice to stiffen up the paper though. So I still have, I don't know, but normally I make much bigger Rubanoids, so this might be easier. I mean, it doesn't have to be really insanely stiff, because a 30 centimeter floppy coil is harder to center than this 4-5 centimeter one. I'm not sure yet. If anyone has a good idea for gluing the coil to paper, that would be great. But fast is always, I don't like to, you know, like set it and then wait for a day. A day is too long. I want to know as fast as possible if it does something. I had best of luck with the cyanacrylate, although it is messy and really messy, but it does gets really stiff. Vinyl sheet, as membrane or as I don't know, because what's on vinyl, is it acrylic glue? Because that's damping as well. Yeah, I believe the glue on that is also kind of a rubbery kind of glue. So I need something that hards out. Maybe polyester might work as well, but it's really messy, and if you ever use polyester, two-part polyester, the smell is terrible. But it might work. I did buy a lot of polyester just for this kind of stuff. Instead of paper. But vinyl is really floppy. So I need something stiffish. Paper has a benefit that it damps as well, but and as well light. Good damping. Damping and stiff is not. It's not really two things that go well together. Usually, it's one of the two. But the coil itself, where the coil is glued onto the coil former, the paper in this case, needs to be stiff. At least I had the best result doing so. If you want to reach high. It's always a sort of balancing thing, because if you damp it really well, then the low end will be much better, lower distortion, etc. But it doesn't extend as well. That's why most woofers are probably heavy for the low end and, well, tiny and stiff for in the upper range, like a dome, which is of course a rather nice shape to make something stiff. While still being light. Yeah, before I can print, I need to prepare some mylar and such, something I'm not looking forward to, so I'm not even sure if I will be printing today. But I'll save this. Coil 101 print. Yes, let me, maybe I can set the printer as well before I forget. So if you wanted to know, I'm using the Xerox Phaser 8500 wax printer, and I always use the tray 1, the manual feed thing, because otherwise it might like be a mess inside. And I can save this so I don't have to do that when I want to print it. Britstick. Well, Britstick I did use for many things, but Britstick is also not gonna dry up hard. It remains rubbery. Yeah, and it's not. It doesn't like heat as well. If you want to get things off, just doesn't like water as well. Warm water especially. I use Britstick to glue the aluminium laminate to a A4 paper. Just one stroke of Brit to make the feeding in the printer easier. Starch glue, yeah, that could well be. I don't know. Has a specific smell and taste. What grade of epoxy did you use? You can bake it to force cure. That's indeed true. They offer Wii Snap Cure. What's that? Fergus. I used 2-part epoxy from, I don't know. There was this. It's probably in my bucket of gazillion links with good sources for materials. Yeah, these 2-part epoxy, that's still rather affordable, but there's one thing about the glue, the bottles that it comes in, they rupture at the corners. So eventually I have like a huge, that's not even shelf, it's like a what is it, it's not a bucket, I cannot find the name. Well, something where you put bottles of glue in, and then it like smooched all over the place, so everything was covered in epoxy. It was really dirty and nasty, so I'm never gonna buy this epoxy again. Although the epoxy itself was rather nice, but the bottles, they're terrible. And usually you have to make more epoxy than you use, so it becomes messy real quick. I'll probably go back to these, these 2-part syringes. They're quite clean to work with, and if you just don't need that much, it's rather nice. And then if you take the 5-minute one, then of course it's still, it needs like 24 hours to dry. I mean, you can work with it for 5 minutes, but it's not dried. To reduce brittleness, snap cure. How does it work? I mean, I know if heating epoxy, first it will make it more like fluid, which is ideal for this, so it can soak into the paper as well. That's what I used before, like heat it up and make it like really like water, and it soaks in the paper a little bit, and it adheres to the coil. And then if you, it's still rather hot, and then if you squish it between 2 pieces of polyethylene or HDPE in this case, so it doesn't stick to it, and weigh it down, and you get like a really flat coil. But still, it's more bendable than, for instance, cyanoacrylate, which is of course brittle. But. My first one is gonna be, I guess, the spray glue, because it's easy. You can just mask it off and just spray a little bit, and you got glue where you want it. And I think I'll start with that, although I know it's not the best. It remains floppy as well. And then of course different thickness of paper. I got 120 grams, 80 grams is I think way too light, so I'm not gonna even try it. But I got some weird papers with aluminium backing, for instance. That's gonna be doing something different. I wish I still had like Nomex, but I ran out of Nomex, I think. It's an ideal paper to be used. It's stiff, it's not paper, so moisture is not an issue, and you can get it in all kinds of thickness, and it looks good as well. At least I think it looks rather nice. I think it's Nomex 410 I used before, the rather thick one, but you can get thinner of course, but usually you have to get like quite a lot. And if you want to try stuff, I don't want to have rolls of Nomex, which is really expensive. Might as well try the foam thingies again. I used a foam membrane once, which was able to reach really low, which could also be a benefit. Yeah, it's polyamide, yeah, indeed. It's rather nice material. I also tried this FEFEC or I forgot the name. Well, it's the same stuff they make these suits for, this hazard suits. Also the underwater paper. Some cards, maps are made of this stuff. So if it rains, it just remains okay. It doesn't like become a mess. FEFEC, I believe it was. So you can, there's a lot of materials you can try, which is fun. That's the fun thing usually. Of course, in the end, you want to find something that works, but just trying is kind of fun as well. If you got any other ideas for paper, then please shoot. So I did try washi paper, and I did try as well balsa wood, of course, but didn't work out. What did I use? Well, aluminium laminated paper, one-sided and double-sided. It had some benefits, but if you once like make a dent or something, then it's kind of screwed. What else did I use? Plastics, of course, loads of plastics. But it usually was too heavy, and if you get it like thin enough, then it's too floppy to be used. Polymedium, but that's like Captain. You mean Captain? Hey. Oh shit, I enabled my own sound, I believe. Oh, that's not the... Well, Captain, also you would have to use like very thick Captain to be able to be as stiff as paper. I mean, stiff. It's not might not be the right term. I don't know. You know, it has some sort of. You know, it holds shape. Let me put it like this. It holds shape. Captain, if you make it thicker, of course, it holds shape as well. But I think it becomes heavy rather fast. Yeah, it's funny. Is Captain more noisy than Mylar? I believe it is. Although people say, yeah, I used Captain over polyester because it's less noisy, but I never noticed this, to be honest. To me, it's noisier than Mylar. But all the Mylar I got is not stiff enough. It's all too thin. And if you go to 0 point something millimeters, it becomes too heavy. I often went to like these art shops and just, you know, they have like these walls full of papers. And I'm just opening up every paper thingy and just, you know, feel the paper and the structure and whatever, you know. Every single one. It's like, yeah, that's too heavy. Ooh, this is kind of stiff. I have one paper that's really nice. I don't know what the name is. Let me check it. Black. It was this really weird paper that had like a. It has some texture, but only in one direction, which makes it really nice. So you can, like, if you use it in the direction you want to be a little bit stiffer, you can use it that way. Okay, so they got so many papers, they're not having them all online, which is, I understand because it's so much. But art stores are really not my wet dream, but I can really like be there for hours. Just rice paper, yeah, I did use yashi paper, or what is it called? But it's like really fibrous and kind of transparent almost. Rice paper I got as well. It's like the paper I roll my cigarettes with. But that's too thin, of course. No, I don't know what kind of paper it is. It's just black paper. It's a little bit. I think it's 120 grams, and it has a really tiny pattern, but only in one direction. So you can make it stiffer depending on how you, in what kind of direction you bend it. So it's a bit like carton, like ripped, but of course far not as heavy and not as deep, but still be rather light. I might still have some of the black paper. Let me take a look. Can't find it. It's stupid because there are a few art stores I went to, and the one in Amsterdam had this paper that I loved really well, or liked very much, and the other art store in Den Haag where I live has the same, but it somehow doesn't feel exactly the same. Same goes for this foam board. I have like really thin 1mm foam board, which I use to make membranes for this kind of loudspeaker as well. But I can only get it in Amsterdam, so I really have to like travel an hour by train and spend, I don't know, 18 euros to get there, just to get some weird materials. Aerogel Captain Composite. Whoa. I've seen aerogel a few times before, but what is it? Is it just glass fiber? Yes, for planar transducers it is, but Fergus, I'm making a Rubanoid, which yeah, maybe I didn't mention, but let me see if I got a picture of that Rubanoid. I got my own, I guess. There we are. So for instance, this is a here it uses this foam stuff, but hey, this is a measurement of mine. Not bad. Absolutely not bad. But I'm not sure which one this is. So, for instance, this is from Sergi, I think. It's like these butt cheeks speaker. It's also one of mine, but a weird one. So you might be able to use. This one is from James. Very nice and neat. He used paper as well, and the Helbach array was his idea, I think. Oh, here's his. It's funny. We made kind of the same thing. Well, of course, we used both the Helbach array, but. Here I just used Nomex, I believe. If there are any benefits, well, it's hit and miss for me, to be honest. I always struggle to reach 20k, and if I look at this measurement, I eventually did, and then decided not to use it. Not sure why. If you look at the distortion here, which is hardly visible, but I don't want to. It's rather lowish. But I think I wanted to be able to play lower as well, but that never happened. But I always made rather big ones. But they don't have to be as big. This one is gonna be a tweeter, so if I could reach this kind of distortion as I've did with the bigger one, then I'm pretty happy. If I can reach like 20k or 18k, then I will be really happy. Because I know James made some really nice tweeters, and the efficiency is really high. That's one of the benefits. Efficiency is really high, and distortion is usually rather low. downside with, I believe, the ones James made was that he had like huge peaks and dips, or at least a huge dip, I believe, in the upper range. I'm maybe he's still busy with it. Might be as well. I don't know. But he asked me a lot of questions about Rubanoids, and he used the Hellbach array for the first time. I used normally this kind of magnet setup. If I can find a normal picture of that, like a normal, easy, just two pieces of steel and a thick magnet in between. That was ×2. That was the motor. It's really cool if you want to have a lot of coil and a lot of travel. No, I don't have any normal pictures here, at least. But yeah, benefit normally is rather high efficiency. But it remains to be seen. I mean, it depends a little bit on the thickness of or the weight of the foil. And I never used this kind of setup with all these tiny magnets. Might as well be a complete fail. I don't know. Although I must say that I never reached the 1 Tesla, so I'm curious about that. I mean, I used cheap magnets, and I didn't use steel, that's one thing. So I didn't use steel, have a rather high field, and there's not much field loss like around the thing. It's really contained, kind of. That's the benefit of this Hellbach thing, which I didn't know existed. It existed, of course, for a very long time, but if you don't know. Efficiency related to sound quality in any way? No, it should not be. It's more. If you want to use like big ass woofers, then it's nice if the tweeter can keep up with it. And if you want to use tube amps, then you have to have a tweeter that is kind of efficient. It's not that a high efficiency thing sounds better in general. I mean, in this case, it could be that the power handling is not high for this thing, and it doesn't need to be because the efficiency is so high. And then you can thus use a lighter coil than if you have a low efficiency. Because if you got like low efficiency, it has to handle, or it has to be able to handle some power. So there is a benefit. You can make it lighter. But all my full range planars are not efficient, and it's perfect. It works perfectly fine. It's no problem. But with tweeters, you usually want to mate them with some other speakers, and then efficiency is kind of a thing, depending on what you like to build. I mean, I know a lot of people that likes horns and such, and have like huge woofers, and use tube amps. And they could not use something like my rubber magnet tweeter, for instance, because it's not gonna level with the woofers in any way. Or you have to go full active, then it's no problem, of course. But and I can understand that it is kind of funny to play loud with just a few watts. Although even normal systems, 2 watts or 3 watts is already quite loud. Even if you have like 84 dB efficiency like my full range planars. You know, at 1 watt, that's 84 dB. At 2 watts, it's 87 dB. At 4 watts, it's 90 dB already, and 90 dB is quite loud. To me, at least. it's not, you know, it's like yeah, like where can you compare it with? I don't know. 90 dBs is loud for in room. Might as well draw a foil when I'm at it because I'm doing nothing. So this is my magnet. This is my frame. My frame has several slots to be able to make a small membrane, see what it does, or make it wider as we go. So I don't have to make a new frame. That was the idea, at least. So if you look at the frame, and I have a coil former. These are the coils, and it has to be on a flat piece of paper or whatever I'm gonna use. That's slightly bigger or wider than the coil itself. So let's make it 2 centimeters. That's still rather small. Let's make it a little bit bigger. Something like this. Then if we're gonna bend it, you see I can choose like different sizes of the ass cheeks. And the bigger you make them, the lower it reaches. But this slot here is gonna be deeper as well, and that's gonna hurt your vacuum cleaner, yeah. Depending on which one, because nowadays you got rather silent ones. Mine is like shouting, but but the deeper you make this ass cheek, the more problems you will receive in the upper ranges usually. So if you make them shallow, like for instance, you can also, if you got this circle, you can move it like backwards or forwards. You can also influence the ass cheek depth. That's, I think, the technical term for it. So I've set my frame for this at this moment. So that's rather big ass cheeks. But let's start off with that. And then we have some paper that's going to be sitting here, and I need a little bit of paper here to add the strings or whatever I'm going to use for damping. So now I'm going to check how long this is. .6 centimeters. So this is the length of my foil I need. And then I got 8 millimeters sticking out. Then where the coil is gonna sit is gonna be 230. I might use a printer to, you know, see where I have to stick the coil and then just cut it by hand. That might be easier than using the plotter. Check out the Rubanoid on her. Hey, boys. So after 50, then we got the coil, which is also 50, I believe. 40, and then 50. And then once more 50. Jesus. Now, how high did I make it? Pause. So the thing is not allowed to be higher than 8 centimeters. So it's gonna be less than that. Seven 40. And then my coil is gonna sit there. Let me check that. But in the middle if possible. So let me grab the middle. Is this the middle? Looks like it. Something like this. Now what I usually do is like shave off a part here. So I'm gonna make some wings here. To reduce weight. But maybe I'm not gonna do that the first time. Then I'll have to draw a line where it has to split. So it's two pieces, two of these pieces, and they're glued together up till this point. Or a little bit further maybe. A little bit further I'm afraid, because I need to put a string through it. So that's annoying, but yeah, that's not ideal, but so it's going to be 100 from the coil. You can see it becomes quite a big coil former. So this is the whole coil former. Yeah, that's also an option. Well, I once made a coil former out of 0.3 millimeter, what was it, carbon fiber sheet, and then like put a very small strip on the back side, like here, like a brace, so it remains really stiff. I mean, yeah. You can hardly, well, of course you can bend it, but I mean for the thickness it has, it's really stiff. But then again, the stuff itself is rather heavy compared to a piece of paper. But I'm pretty sure I'm gonna use the carbon fiber once more to see what it does. Benefit from having only the coil former from carbon fiber is that you can just glue on different kinds of paper and see what it does. that's not gonna work. I mean, the mylar is gonna just flop around, and the paper in the honeycomb will be heavier than a piece of paper on its own. I have like 40 samples of materials glued together with with their weight draw on it. So I made a lot of materials and see how stiff it was and what the weight was of all the materials to see what I could use. Also honeycomb polyaramide with paper or Nomex sandwiched. It was light, it was thick, and it was still heavy. Well, it's not heavy, but heavier than a piece of paper. I believe the carbon was rather light and especially really thin, of course. I mean, it was 0.3 millimeters, and it's, you know, it's flat as anything. But it's still the question: can you transfer them to? Can you transfer the, you know, high frequencies to whatever you're gluing on that piece of coil former? And what kind of glue do you use? So this looks rather big, to be honest. It's a bit bigger than I would like. So this membrane is quite high compared to the coil, and especially if you compare it to the magnets, which are only 30 millimeters. So my hopes for this big ass membrane is that it does emit high frequencies where the magnets are sitting, and as well give us a little bit more oomph down low. So because it has like a bigger thing, it moves forward and backwards. But still, it could be hurting the top end, and I have to make it smaller. Might as well be the case. So from the coil out, from here, 100 did I say? That means 10 millimeters in my world. So that's where the holes are gonna be, and a string will be there or something. That's okay. And I have to do the same on the back side. So from the coil out, 100. Here there's supposed to be a string. There. There's not much flesh left in this piece of paper, to be honest, to puncture a hole and hope for the best. What we'll do. I don't want to make this even larger in this direction. I mean, it becomes more heavy. Why is this so huge? It's almost a centimeter of hangout. Because here's the coil. It's just these blocks are rather heavy. My other option was use like something like a rubbery stuff instead of a string, and then you just put it here. So you can lose this piece of paper as a suspension. That's why I bought some rubbery materials for slingshots and such for this reason. But we'll first try the simple method. I mean, I got lots of coils, so I can just fuck around. Here we need another hole. There. That's a bit too big. there, one hole there. Oh, that's annoying. I need this points. Also, you can try and lose a piece of this by drilling holes or whatever, or cut out a piece. But of course you lose some stiffness as well. Yeah, I've tried that once, like a sort of miniature thingy in the middle. Yeah, I had the same idea. Didn't work out back then, but who knows. Quite a lot of paper for such a tiny thing. I did like, you know, calculate it, but it looks quite long. It will fit in the width of a A4 letter, which is good. So I can print 3 of them. Yeah, probably just gonna print them and just cut them by hand. I mean, then I can at least you know, see where the coil has to be and just put it in the perfect spot. That would be nice. Also, it's if you draw something, and usually for me at least, it's if you make it, then you think, okay, this has to be different, this has to be different, this is not okay, that's nice, that's not okay, I have to change that, blah 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 blah. So I might as well export this one as well and print it out a few times. Why not? Explode. Oh, I do need to know where my glue line is. That would be nice. Is that here? No, where is it? So I want it to be glued up till here. Might need to move my holes a little bit inward. Like 2 millimeters. I hope I don't run into problems then. So the string will be here, rather close to this piece. God damn it, they have to be larger even. Let's move it 1 millimeter back. And then glue up till there. So this is something you can play along with for hours. I mean, you can change anything you want, so and nobody knows what is correct, so oh. too much. I only have to see a outline. This is enough, I guess. Can I fit 4 on them? That would be nice. Probably no. No. Only on one of the papers the coil is gonna sit, of course. It's FEMM, yeah, it's called FEMM. Why does the moving part needs to extend beyond 90 of the throw? Yeah. You mean why it doesn't stop like here? Because that's also what I did a few times. That is possible. So what I did was like moving all these things towards here and play with that. Yeah, that's an option, but that's the thing. There's so much things you can try. And indeed, you could like use this as what changed. I believe distortion went up in the lower end because this has sort of a natural movement, like rolling. You know, like it moves like really smoothly because it's kind of a roll. And if you put like where it is fastened over here, it's more like a speaker and more shout. I don't know, you get more resonances, but it might help the top end. I don't know. I noticed that if you make these ass cheeks flatter, so moving where it's held a little bit outwards and make the ass cheeks less deep, work best for my top end. But then again, it's almost every time it's hurting one of the two. So if you got better top end, it screws up the low end, and vice versa. In the true Rubanoid, it's like, and that might be the reason why it still is like this. Because in the true one, it is. Can we flip this? Flip. Why am I not allowed to flip this? Wait. Maybe now I am. Flip along red axis. The true Rubanoid was like this. So yeah. 2 ass cheeks. And then you got like 2 of these rolls, and you hardly need anything to center the coil. Just a few strings that hold it upwards so it doesn't like sag. This design works too, but the distance between this membrane and this membrane creates a huge dip, of course. And yeah, to me, the frequency response was nicer when I cut off, when I cut off this ass cheek. For me, it looked much better then, instead of the original Rubanoid design. Of course, I put like all kinds of damping materials inside, but still, it wasn't perfect. And when you cut off the backside, then you have not, you don't have the problem of two transducers that are transparent sort of and sitting like a few centimeters apart, which actually the original Rubanoid is, of course. Because this ass cheek moves outwards, the back one does the same, or it moves inwards in the same direction. It becomes messy. So cutting off the backside had another benefit of losing a lot of weight. Mostly, I guess, this weight here in this region. Because here it doesn't really matter what you do for the top end in terms of weight. It all emits from this part. Three magnet groups. You mean like above each other, like putting two of these here one and here one? Because that's possible. I chose to use a oversized membrane in this case because that's the biggest I can go in this frame, and I will scale it down to more like the magnet height. So I can lose this part without any problem, and the same goes for this part without any trouble. And I can even squeeze down the coil a little bit, I think. But then you will end up with indeed a tweeter. And I still I still got my hopes and dreams up for having a tweeter, that's fine, but a tweeter that can play as low as I can get it to go, while still have a okay top end. Top view, put an area on either end of the membrane. You mean here, and then have only this, because that's what a viewer. No, a viewer created this actually, and I still didn't try it. So more like this, and then like this. And then the coil is sitting here. And here. So the magnet area will be here, and one here, and one here. Now what's happening, this will become larger. So if they both move inward, this moves like this. And he experimented a lot with it, and well, it's his project. I feel like if I try this, it feels a bit like stealing his idea or something. I mean, of course, this cannot be this strong of a curve, so this should be more like I don't know, more like this, and this one more like. It's something I want to try still, but a problem with this is, at least what I think, I mean, he told me he had a lot of low end, so it could work very nicely for low end. I don't know. I mean, he doesn't have measuring equipment, so as long as you don't are not able to measure it, it's kind of hard to say if it works, yes or no. At least if you want to convince me, I have just no clue if it works or not. But the problem, what I think is the biggest problem, is that the top end in a Rubanoid mostly emits from this throat part. In this case here, you got like 2 of them. So it might emit high frequencies up till here, and this one does the same. Then you have 2 sources, which is quite not a nice idea. So what you could do is like make this part heavier or something, I don't know. So that part, so it doesn't emit high frequencies, and it does help with moving this bending thing. But then again, then it emits only high frequencies from here. And this looks quite similar to the air blade. The air blade does kind of the same, but uses only 1 motor. How would you like to drive the middle part? Because that's not, if you would like add magnets, it has to be another kind of magnet array as well. But if you would put a magnet here, for instance, it's moving sideways. In this, if you use this kind of magnet array, if you use like normal planar magnetics, it would like move front to back. But if this is like pushing it like in the lower end a lot, you know, like let's say 50 hertz, which is really low of course, but this will go back and forth, and if it plays at the same time some top end, the top end will like modulate with the lower frequency, so you will get some nasty distortion. That's hard. This is so hard. Okay, top down of the original design. At the post you are attaching the outside of the paper membrane. What's the outside? Oh yeah. But then you get like this, sort of. But then times 2. Okay, I know what you mean now. Okay. So leave this the same. Do this. Oh, wait. Do something like this. With the coil would be nice, but you know the drill. Let's like flip it. Something like this. Add this. I'm gonna screw up my image now, but I saved it, I think. And do something like this. Wait. There. And here. And use 2 of these. Yeah, so you got 3 magnet arrays. 2 of them presumable doing only like low end, like filter them. Yeah, indeed. And do the mid part for tweeter duty only. Might be a really good idea, I don't know. It's worth a try for sure. Yeah, could be fun. The only problem, but that remains, I mean, if I fix it in single ended, is the top end with this ass cheek. That's a problem. It creates a dip and a peak usually, so if I can fix that somehow, then this could be could be something worth to try, definitely. Yeah, it could be fun. It could be like completely going wacko, but it is that seems like a cool project to try. I believe someone did this. I think. It's in this huge motherfucker. Ah, James is on DIY audio all of a sudden. So this is. That's not clear. He did something the same, I think. That looks different. Ah, here is a response, for instance. It's not that bad, actually. But I believe there was someone that did it. But I think he used 3 rolls or something. These are all paper ones. Oh, he made a really nice coil winding thingy-majiggy. Not bad. Really nice. Yeah, I made something similar to this. It works. That's me, by the way, on DIY audio. Yeah, there is one that this topic is so huge. It's 120 pages. When I like watched it every fucking single day, yeah, there was one which had this is the old design. Use huge motherfucking or old design, the other design, huge magnets, huge. That's no fun to get this thing together. But yeah, I will try it. I'll first try it like simple, but it's a good idea for sure. And if it's done or not doesn't really matter. I mean, yeah, it is a funny idea. I thought as well with, you could also do, if you would make them bigger, you could do the same. You can, like, for instance, if you make them twice as tall, you can add like several coils. So, for instance, you got like one, so 2 base coils, and just because usually the top end is a little bit more efficient, and just add a tinier coil in the middle. Oh, all on one foil, just for fun and giggles. But good one. So it is nice people chipping in. I mean, it's not often that people just sit around and spam ideas, because that's how you usually come to the best ideas. I mean, it's faster than doing it on your own. So I created a lot of mess. This is the work of one day. Apparently, it looks like shit, but who knows? Oh, let me print out a few of these. We can use the normal printer for that. I don't need a fancy wax for this one. Oh, I just didn't put the right paper in. Because I wanted to start off with 120 grams. I have to hand feed it, I guess. Hey, puss! How does the fuck work? How does this thing work? Never used this manual tray on this printer. It's a very cheap ass printer. Print you. I want to use the tray. Handmatig. Yes, please. Oh, it takes both. Oh, it's so funny if you have stuff in your hand, it's so different. It is actually really tiny. Everything is really tiny. Yep. I hope I can etch these foils because they're really incredible tiny. I hope that works. Might be a problem. Otherwise I have to make the tracks wider or go wires. Although I don't want to go wires. I like printing out 20 coils instead of making one by one by hand. I wish my coil here. Maybe you got some ideas about that. Who knows? Coil pancake winder. I once made this, but it cannot make the turns. It can make circles, which is nice. But it cannot make these tight turns as used in, for instance, this coil. If I ever find a way to do so, that would be so awesome. There's so many projects that I want to make then. Because this is really tightly wound, really cool, but I cannot get the circle smaller than this. Would be nice. Here, you got a perfect flat coil. I would be really glad if I could make this smaller in size. But apparently that's hard. Could you imagine you have a plier magnetic with these amount of turns? You can make something very efficient. And I have the mylar only just there to hold the whole thing together, but yeah, have a nice dinner, George. I'll be having dinner soon as well. Just smoking a last cigarette and then I'm off cooking as well. No problem. See you next time. Thanks for watching. So I printed out a few of these. I'm gonna have some dinner as well, I think, and after dinner maybe print the coils and etch them. See if I can make one membrane. I'm really curious. I need to make one before I go to bed, I guess. Even if I don't want to, I need to, I think. So yeah, thanks for watching, and Fergus also, thank you for the nice ideas, and George as well. Seeing you next time. And there's one just dropping in, just a little bit too late, because I'm just shutting down to have a nice dinner, hopefully. But I made a a membrane, and I made a coil, this coil, and I did some FEMM. But you can look it back if you want. So see you around. Bye bye. Thanks for watching.